Hello and welcome back. My name is Corey and you're my rubber ducks for the evening. And this is the series of episodes where we are creating a programming language from scratch using just basic tools like Flex, Bison, ICU, Google Test. C++ is our programming language of choice, and Vim is our editor. We're doing it all in a terminal window, and none of this is pre-prepared. The goal of this series is to capture the creation of a non-trivial project from start to finish. Our project's ever finished. How about from start to useful? And capturing it all on video. So that it's 100% live coding. I've said nothing up my sleeves. I don't have anything pre-prepared. That means you see all of my mistakes, all that stuff. Well, we are on episode number, what episode number was that? Episode number 77. Wow, never realized it would be that much, but let's see. On the right-hand side, we're going to do our standard make clean and then make, just get it started compiling so that we know we have to start with a clean compile. If we look at our log, we'll see that the last commit was the end of the previous episode. And if we say git status, there is a difference. And actually, at the very end of the previous episode, I made a change and I did not commit it. I said we'll take care of it at the start of the next one. So if I say git diff, all that it was is we removed some stuff from our global to-do involving the percent encoding. Now, we've got percent decode here. We don't have that added yet. I don't know if we're going to. We don't need it for the template. So I think I'm going to leave that off for right now. So with that in mind, git commit, and we're going to say update global to-do by removing completed percent encoding tasks. Sure. Okay, so that has been created. On the right-hand side, we can see that all of our tests are passing. That's good. And now let's, we're going to start. What are we doing today? Well, according to the title screen that I created, I know now why a lot of YouTubers will record the intro last so that they know what they're doing. Mine are aspirations. That is, it's what I hope we get done. And that is, we want to have better tracking of our location. Right now, we've been passing around a location, but we haven't really been using it. And we need to make better use of our location stuff. So the first thing we're going to do is, the nice thing about, I'm in Windows here, and I'm using the WSL, Windows Subsystem for Linux 2, to do the programming. And because ultimately where I see this running is on a Linux system, and so, might as well be running it or developing in that environment. And we've been using Doxygen to generate our documentation, and one of the nice things about the WSL is that it has WSL view, and we just say, what do we look at, and what does Doxygen generate? Well, it generates a PDF and it generates an HTML website. So that's what we're going to look in, and just use the command WSL view, and there we go. This is on our local computer, but we can see this. So what we want to look at is the location class. Do we have that here? Oh, point and location. Okay, so location and then position. And what it is actually, if I go down to files, file list, under the build generated, there's location.hh, and we'll see that it has two classes included. This is created by Bison, and I specifically told whatever that thing is called, specifically told Doxygen to include this. And so in the doxy file, I told it to include this file when it scans for stuff. And so that way we can see what's going on. And there's a couple things I want to see. First of all, so we've got location, and that is 2 points in a source file, and we've got position, so that is a point. So a location is 2 positions. So location, we see here begin and end are positions. And what does the constructor for location look like? We can have a begin and end, or we can have a 0 with location. Okay, that's fine. So if we give it just 1 location, file name with a counter type. Oh yeah, that's L. I would assume C is the lines and columns. That's it, lines and columns. And we can initialize it to some value. Step, columns, lines. Yeah, I think that's right. Begin, end, that's fine. And those are positions. So when we create it, all right, what about a position itself? A position, well, wait. I want to go back to the location. That's all that includes. Okay. Position, we've got a file name if we need it. We don't. That is, we're taking in strings. So we're not using file names. The counter type, okay. And it's just basically an int. So that's for counting lines and columns. It's an int. So creation, lines, columns, lines, columns. And then we've got some operator, plus equals. And this is for a what is this on? Okay, so position, we can add columns. So plus equal or add with columns, subtract with columns. That is for join 2 locations in place. So if I location and the end, location end, join 2 locations. Does that mean I get the start of one and the end of the other? Or does it... Let's go down to... by the way, like I said, this is nothing pre-prepared, right? I'm learning this like you. I have some experience with it, but... and I don't have anything other than position and location, blah, blah. Okay. Well, let's get started and and kind of see what we end up with. I am going to edit. Let's go with flex, because ultimately this is what gives us our positions, right? So what do? We've got our YY user action, and we step forward location, and then we go I is equal to 0, I is less than YY length. So we're stepping through, and we say that if it is a new line, then we set the column to 0, and we increase the number of lines. Else, we increase the number of columns. So what does location.step do? Location, reset the initial location to the final location. Oh, the previous end is the new beginning. Yes. Okay. So how this works is that YY user action gets called, or it's a macro that appears in place, and so we say, well, this is after we've recognized some thing, some token, and we do the location step, yeah, all of this stuff. Okay, that's fine. So location will always be the current wait a second. Is location already the number of or the size? That's a very good question. So here's what we're going to do. We're going to edit test.cpp, and go to the very end. And what are we going to do? So that we know, all that we're going to do is we're going to tie into our source for AST node use, because we know that it's in the very last one. And we know that we've got a location available to us. And so let's go into the compile, because we know it's going to be called, and see out something. What if I just see out this location? See what happens. (2.7-9). That's interesting. So 2 would be I want to look at the function. Edit the source for AST node function declaration. And I'm going to do the exact same thing for the compile. Look at this, 2.5 to 2.12. All right. I bet you the first row is here. 1 is here. 2. If I go all the way to the beginning, that's 1, 2, 3, 4, 5. Maybe 0, 1, 2, 3, 4, 5. Does it start there? 2.5, 6, 7, 8, 9, 10, 11, 12. Seems like it's one short. Could just be in the way. But if that's the word function, and this one is... oh, wait. I should be looking at the last 2. Right? Here's how we find out. There. Yeah, 3.7. Okay. So 1, 2, 3. 1, 2, 3, 4, 5, 6, 7 is the F. 8, 9, 10, 11, 12, 13, 14. N. 7.14. And then if that's 3, 7, the next one is 4. And if this was 7, 8, 9. So that is, all right. Now, I want to edit Bison. And I'm looking for function declaration. Yeah. Okay, its thing is at 1. What if I say plus, what is the last one? 6? At 6. See what this gives me. And if this works, then this will be a lot easier than I thought. Let's go back to B2. There we go. And 3.7 to 8.7. So 3, 4, 5, 6, 7, 8.7. That would be the last one. And then the next one is 4.9 to 6.9. Yeah. And if I change this, it'll be 6.1. Don't know why it decided to recompile everything, but it did. Yep, it did that 6.1. So, okay, all that I need to do now is to start going through and say, yeah, start going through and putting the endings. So, first of all, let's B4. We can remove that. B3. B2. B1. So I didn't have to do anything different to any of these. We just need to be in Bison. All right. So now I'm going up to the very top so that symbol type YYLEX. Sorry. If I only have one item, then that's all I can do. But if I've got more than one, like this here, I think it needs to be Okay, so these are AST nodes, right? In other words, am I capturing their location? So expression list is a set of expressions. Each expression, okay. Anytime that I have to have a that's the identifier, which is a string to that. Okay. So what I'm thinking is anywhere that I'm using the at sign, at 1, it needs to be plus at and whatever the last one is. In this case, 7. Is that right? 1, 2, 3, 4, 5, 6, 7 is close statement. Okay. This one, plus 5. This one, plus 7. Those should be at. This one should be plus 9. At 9. This one should be the identifier is fine, but then the 5, so this would be plus at 4, 5, 6, 7. Already did that one. This one, a return. I'm going to say plus at 2 so that it gets the entire thing. Oh, wait. I think the at 2 would be on the outside because what it's returning is a null, and that's just the 1. You know what? I think they can both be at 2. Yeah. How about this one? Return. Okay. So plus at 3 plus at 2 plus at 2. The string, there is no other thing. Okay, it's just a string. Plus at 3, and this one will also be plus at 3. Oh, so the template string is the preceding one. So do we need to do this slightly different? Yeah, I'm not liking how this is coming out, or this particular one. So what goes into quick print begin and string? So we're on 5. Let's go back to 1. Quick print begin and string. Okay. We pass in the string buffer. That's everything. But we've read in an extra %. So it's going to include that. For right now, let's leave it as this, and we'll probably come back to it again. Well, there. And now this is going to be 2. At 3. All right. This is going to be something kind of similar. At 3. All right, so the library is at 1. That's fine. However, this is plus at 3. Okay. Plus at 1, 2, 3, 4, 5. There's 5 things there. Just give myself a little room so I can see what's coming up. That's fine. This would be at 1 plus at 3. At 1 plus at 5. At 1 plus at 7. At 1 plus at 5. At 1 plus at what? At 9. That's the last one. Okay, this is the HTNode identifier, and just it's at 3. Okay, and then this is 1 plus at 7, because that's the last one. Okay. At 1 plus at 8. At 1 plus at, this is again at 6. 1, 2, 3, 4, 5, 6, yep. 1 plus at 2, okay. Plus at 3, next. Single, single, single. All these are single ones. This one is Now here's a question. It's an assignment, but the assignment is the entire thing. do we say no, it's only at the position of 2, or is it the left-hand side and the right-hand side? At 1 plus at 3. No, I think I would rather have it as at 2. Because the expressions themselves will be, whatever. Okay. All of these are fine. Yeah. Plus at 3. Okay. This one, can I say location is equal to at 1 plus at 3? I think so. Plus at 4. This should be a 2 because the dot, the period, is, yeah. At 1 plus at 3. The index expression, we're going to say that that is an at 2 plus at 4. Same thing here. Yeah, that's fine. At 2 plus at 4. Okay. And that brings me all the way back around. So now we're going to see AST node has no member named location. So that's the only one I didn't know for sure whether or not it would let me do. So an AST node it has location. It's protected. Should it be protected? Or is it okay just to make it public? I don't think I have a get position. No, I don't. Okay. So we're going to edit our source, no, our include for AST node. It's no longer protected. It's public. And now we'll see what happens. The quick answer, by the way, is nothing. That is, I mean, it should just work. Okay. Oh, shared pointer, of course. This is 562. There we go. It's a shared pointer, so we have to use the arrow to get to the actual value. All right. By the way, that's good. So now we're tracking the beginning and ending positions, and that is worthy of a commit, I think. Git diff. Let's see, what all changes did we make? All of these seem reasonable. If I had known it was this easy, I would have been doing this from the beginning. That way we wouldn't have to spend 30 minutes on a refactor. All right, simple enough. Now, what can we do with annotations? I think if we edit our include for program, and our source for program, so our include first of all, what is an annotation? It's a comment, right? But I see it as a map of size t, because it's going to be a bytecode offset to a string. Annotations. And now we need parameter. It's going to be the offset to associate with the annotation, and at param for the and all that's going to be void set annotation, and we're going to have a size t called offset and a string ampersand called annotation. And then we need a get the bytecode annotations, and its result is going to be a map of bytecode offsets to their associated annotations. And that's going to be a, what did I say? Map of size t to a standard string get annotations const. Sure. And the only other thing is I need to go down here to the bottom and standard maps. Yep. Okay. So we're about to add these. Where are they? They're up here. Set annotation and get annotations. Let's go into the next file. All right, see if that all compiles. And that's just a structure to hold the annotations. Okay. Let's add our first annotation. And we're going to do this with the we need something to display. You know what? So I'm looking for where we declare a function. You know what? This will work fine. Right here. And I just want to see out P6 dump bytecode. And now we're going to look at the source. AST node function declaration. So when we are compiling, program dot, did I say set annotation? Name. No, I'm not going to put that there. Besides, I'm just wanting to see if I can get it to work. Okay, so right now we're just calling the set annotation. That should be fine. And source on the dump bytecode. So for each one of these, we're going to say if this annotation dot count PC for this bytecode offset. Offset width. What is right? Oh, right, justify the program counter, followed by another one, followed by you know what? We can do it this way. All right, so the goal is I just want to kind of put an annotation there, and well, let's see what it shows us. We should have one in that one. Ah, look, jump past the function declaration. The only thing is I didn't include the right, and I should have right. There we go. And function A. Yeah. Jump past the function declaration A. Now the question is should that go before or after the opcode. We just output and why a semicolon? Because I believe that's usually a comment in assembly. You know what? So let's look. Comment. Yeah, usually semicolon. Yeah, that is a bad comment. Don't write comments like that. But normally it's after. It would be better if it could be like right there. But we don't know what all is going to be there. And plus, once we write it, and I don't want to have to do this for every single one. So I think that's what we're going to do. Okay, we'll leave it like that. And let's go back to the function declaration. So what would be interesting is the fact that for each identifier, see, we could add program dot set annotation at opcode location. No, I don't want to do that on this one. Oh. Argument size. So what would be interesting is in other words, I'm just trying to figure out, should we add more information to compiling the function? Well, we You know what we can do? So this would be interesting as so we're going to be adding entries for each identifier. So we could say if, if arguments.size is less than identifiers.size, then program.set annotation, and where it is going to be program.get bytecode.size. So it's going on the very next one. And what are we going to say? Function identifiers. For identifiers. Let's see if that works now. So we're in 4, we need to go to 3. Because this one would be an interesting one. 2. So jump past the function declaration of print n times. Reserve stack space for function identifiers. Okay. Jump past the function declaration inner. Reserve stack space for function identifiers. Okay. I think I want to do the same for the strings. All right, so I'll put that there. function strings. Oh. Yeah, I did. I did forget that. Sorry, you should look at your error messages. So we don't have any strings for this one, but we do have one on this one. So in this one, reserve stack on the function, reserve stack space for function strings, and there is string high. Okay. We could and this can be function body. Yeah, function body, blah, blah, blah. What I'm wondering is function end, if that makes sense, to add a function end. So we've got a function end. Let's do that for the function body as well. You know what? I think I like better. Let's do this. Let's do this as function plus this arrow name plus that. So here's what we're going to do. We're going to say string func name is no. Not a capital. So just start them all with annotation. Body start. Shouldn't be body, it should probably be code block. Make that match. Code block start, code block end. Any other annotations? Oh. Line 69. This should be a plus. I like that a lot better. So we've got this idea. So for the one starting on that one right there, we can tell print in times, jump past, okay, reserve stack space, blah, blah, blah. And then we've got this function enter where we jump past that, blah, blah, blah. Function enter code block ends. And so on. Code block ends. Yeah. So I kind of like this. That is what's going on. All right, now I think there's probably one more that of all things I would I know I just stopped talking because I was thinking, how can I do this? AST node. Oh, that's why. Source AST node identifier. All right. So when we're compiling it, I just wanted an annotation. Okay. And it's going to be warning okay, and I want it to be annotation plus warning identifier not found, as opposed to this, which will be load from stack. All right, see what this does. Yeah, things like this, identifier inner load from stack. And identifier string. Yes. Okay. I think all this is a lot more helpful. They say, well, it's adding a lot of stuff. I know. But we don't need to. So, for example, we don't need to do the greater than comparison. Obviously, it's more the overarching, just trying to figure out the structures. That should not have a colon at the end. That's going to be in 4. There. Shouldn't be any others. Maybe I should put function in all caps just like I do with identifier. I think that's probably a good idea. And maybe, let's see, wrong window. Edit source AST node function call. On the compile, we're going to compile each argument. Oh, because we don't know. Nope, it wouldn't make sense on this one, really. I was going to say is we don't know what the name of the function is. That's what I was thinking. We could say, hey, we're calling function whatever. But no, it's whatever function is on top of the stack. So, all right. That is probably, you know what, I think that's probably good for right now. Let's go back to our tests and we can remove the dump bytecodes. And now I just want to, what would it look like on this very last one? If I were to say cout p1 dump bytecode, would that help us in understanding what's happening? Let's get back our syntax highlighting. There, we've got back our syntax highlighting. And we need to figure out why it goes away. But here we go. Peak 2, yeah, library. Peak 3, period, okay. Poke that into 0. You know what, that might be... No, I'll leave it here. Function f, and we do have a function f, and it has a function enter, and there's an identifier called floor. Okay. Function f enters code block end. This is where we load x. All right. I kind of wish when we're dumping, what I was going to say is basically if we could identify where the end of a statement is, and that's at the pop, right? So for example, if we look at this command, use math.floor as floor, all right? that, there we go. So what did it take to get there? Well, of course, that's loading everything. Peak, so math, call the library, peak floor, period, poke that into floor, 0, and library save, 0. Yeah. And then we get to, that's just that first line. All of those instructions. It might be... You know what? I think we can. Oh, I'm going to have to now remove that. But if I go into the source, okay, and git grep pop, where I'll just pop. So we're basically everywhere where we add a pop, we could add an annotation, but nope, we're not going to do that right now. Okay, so let's go back into find the cout that we put in there. But I do like what we've done here, so that's why I think we're at a good stopping point. And all of our tests are passing. That's always a good place to be at. So let's verify our changes. We've got our bytecode annotations, and we're only adding it to function declarations and loading variables. Okay. But that might be just fine for right now. So we add bytecode annotations in key areas. Yeah. We can add more later if we need to, but that is good. All right, so where does that leave us now? We need to make docs PDF. There we go. And of course, on the right-hand side, you know me, I'll make clean and make test some big numbers. Let's do 24. Why not? See if I drop any frames. Oh, wait. I had a weird dependency issue right there. All of our tests are passing, and we've got a bunch of modified stuff in the docs. Not unexpected. -m update docs for episode, anybody know? Episode 77. Get that pushed up. Oh, hit the wrong thing. What I was thinking, I always forget to edit the include Tang, and that can go away. All right, so what does that mean? What should we do next? I don't know, because I didn't expect this to be done as quickly. I really didn't. We're at the hour and a half point, and that's with me doing a lot of talking. I kind of want to either work on the standalone interpreter. Not really a REPL. I don't want to do a REPL for this, but the standalone interpreter, maybe optimization, start on that. We've got some potential optimizations here. I really like the idea of doing tail call optimization, but also I know that we need to figure out a way of how can we make this just work with other code bases. That's the goal. And Tang version, we could, oh, that's it. I want to add some library macros. How about that? To make creating library objects easier. And we may work on that next time. We'll just say git, well, just to ensure that that is the only thing. Okay, yeah. Git commit dash am and update master to do list, removing location, item, adding library macros. Okay, that's fine. Push that up. Now, get tag dash a. What is this? Episode.077. Is that what I just looked at? I'm sorry, I don't remember. Yes. Dash M. Episode 077. Oh, I could have looked at my log, I suppose, as well. Push origin. Episode 077. And with that, not a lot of code added, and yet a lot of functionality. So I'm very happy with that. Anytime you don't really increase your code count, but your functionality is better. The best are when things are when your count lines of code goes down, and you get a lot better functionality. But for right now, this leaves us in a good place. And again, thank you for joining me, and I hope it was useful. All right, bye.